Hello, today we're going to talk about 3.1, solving systems using graphs. Okay, systems. This is called a system of equations, all right, more specifically a 2 by 2 system of equations because it has two equations with two variables, all right? So this is how you solve it through graphing. All right, the first thing you would do, here I'm going to use two different colors. I'm going to graph the first line in blue. So since it's already in y equals mx plus b form, I'm just going to go ahead and graph that. So we go down 2, and then it's a slope of 1. So then we just kind of connect the dots. Sorry, I know this takes a second, blah, blah, blah. Okay, there we go. So then we graph the second equation. All right, so this isn't in the form I want, so I'm going to go ahead and move that x over. So we get y equals negative x plus 10. All right, so then we go up here, 3, 4, 5, 6, 7, 8, 9, 10. And then it's a slope of negative 1. So then it's going to be this as your slope. So here, I like to put the dots there just so I can draw a straight line so I can see what points it goes through. All right, or you can use a straight edge. All right, just try to make it look good. All right, so those are two equations, but remember we are solving this. So solving means we are trying to figure out what x equals and what y equals. Well, we want to solve both of these equations. And what solves both of these equations is this point right here. So the solution is the overlap, or in this case, the intersection. Okay, so the intersection here, so that's 1, 2, 3, 4, 5, 6, comma 4. That is the answer. Okay, what that means is that that x and y value works for both of those equations. So if we plug in 6, comma 4 for both of those, it should work. So how we check our solution. So we check our answer by plugging it in. So for the first one, we would get y equals 6 minus, ooh, that's supposed to be a 2. Okay, so we get 4 equals 4. That is true. Check the second equation. 6 plus 4 equals 10. 10 equals 10. It worked. So our answer worked. Okay. All right, let's graph another one. So if you think you got it, pause it, try it on your own. If not, watch me again. So take the first equation, we're going to graph that one. So I'm going to rearrange that. That's like y equals negative x plus 7. So again, now it's in the correct format. So we can easily just graph it like this, and then a slope of negative 1. Sorry, I just want to make sure that I go through all the points so it's easy to find our solution. Okay, so that's another reason why I do so many dots. And then this one. Okay, we're going to move things around. So 3y equals negative x plus 7. Oh, this is gross. Okay, something went wrong. Oop, I think I know. All right, this was supposed to be a 9. Sorry. Just slightly fix that. There we go. Perfect. Like it never happened. All right. So then we get y equals negative 1/3 x plus 3. So then we can graph 3, and then down 1 over 3, down 1 over 3. Right. We can graph this. So again, just to complete the sketch. Now make sure you go edge to edge. Okay, it's always how you want to graph it. You don't want to just stop in the middle. Okay, so then here our solution is right here. So that is at 6 comma 1. Ooh, that was a weird in. Okay, solution is 6 comma 1. So we can check it by plugging it in. So we get 1 equals 7 minus 6. That one works. We get, plug it into the second equation right here. 6 plus 3 times 1 equals 9, and that works. So we're good. All right, so how we graph these. Hopefully you remember. Okay, this was, let's see, we have Hoy Vux. Okay, go back to those old videos. Make sure you know how to graph these. So for our x equals is vertical. So I like to also think of it, if you were to make a table, all right, every x value is -3. So it doesn't matter what your y is, x is always -3. So if I'm always at -3, I'm always -3, 0, -3, 1, 2, 3. I'm always along this vertical line. Ooh. Can't draw a straight line. That's all right. You get the idea. I was supposed to go through those points. Okay. For this one, if you were to make a table, every y would be 4. So it doesn't matter what the x is, y is always 4. So we could be at 0, 4, 1, 4, 2, 4, 3, 4, 4, 4. Okay, so then we get the horizontal line right here. So then their point of intersection is -3, 4. Which makes sense because it literally tells you that in the equations. X has to be -3 and y is 4. So that's the only solution. And this is how you graph it. Okay? I swear it's supposed to be that easy. It really is. Vertical line, horizontal line. But every year, kids mess this up. In every math class that I teach, you see this every year since Algebra 1, and people forget it. Know your vertical and horizontal lines. Okay? It's going to make life so much easier. It's supposed to be like no work. It's supposed to be easy problems, but they miss it all the time. Okay? So commit this to memory. I promise it's going to pay off because there's going to be a lot more math you have to remember, but this will save you. Okay, so vocab. Just because, you know, those fancy SAT and standardized tests, they love vocab. Okay? So you start with, you can either be consistent or inconsistent. Okay? Inconsistent has no solution. Consistent has at least one solution. Well, think about what we've been doing here. We've been graphing lines and finding their point of intersection. So, well, how can I have two lines that don't have a solution? Well, hopefully you're thinking, if you have a line right here, I want to draw another line that doesn't intersect. So let's just draw one that's parallel. So if you have parallel lines, they have no solution. Okay, so inconsistent is when you have parallel lines. That's what the graph's going to look like. Inconsistent. Consistent means it's going to have a solution. Well, hold on. Now we can be more specific. We can say it's independent or dependent. Well, independent has one solution. Well, we've certainly done that, right? We've had one solution. Well, all of these graphs have one point of intersection. So they have something like this. That's independent. Now think about what dependent is. Infinitely many solutions. So if I were to graph a line, I need to have infinitely many solutions. So that this other line has to, I don't know, be there and there and there. Infinitely many. It has to be the same line. Okay, so dependent are the same lines. Okay, so inconsistent is parallel. Dependent is when it's the same line, but the two of the equations are exactly the same. And independent is where the equations meet at one spot. Okay? Know your vocab. Okay, I also like to throw in inequalities because I feel like this is pretty easy to throw in there. So we're going to solve this system. Okay? So now we're doing inequalities. We did equations, now inequalities. The best thing I can tell you to do for inequalities is start them the same way. You want to get them as y equals mx plus b. So kind of just ignore that inequality. You get y is greater than negative x minus 1. So now you graph it kind of without the inequality. Okay? Well, hold on. I want to show you something first. So then this equation, let's see, we get negative y is less than or equal to negative x plus 3. But when we divide by that negative 1, make sure you remember to flip your inequality. A lot of people forget that. So when we go to graph our lines, there's something we need to notice. This is equal to, this is not. So then this one is going to be a dotted line. And then this one is going to be a solid line because of the equal to. Okay? So let's see. We're going to graph this one, the blue one. So we're at negative 1 slope. So here, you're going to get the idea. Again, I like to draw the dots because it makes it easier. Plus, I don't have a straight edge, so just bear with me. So now we're going to make this one dotted. You could also make it dashed and do something like this, where you connect like every other dot. Kind of do something like this, whatever. Okay, that's your dotted line. Then your solid line, because it's equal to, is going to be this one, so negative 3, then our slope of 1. Okay. Ooh, can't draw a straight line. Bear with me. Ooh, there we go. All right, so then now what do? We also have to deal with the inequality. Okay, so because it's greater than, that means we shade above the line. We shade above the line. So everything above the blue. So I like to start with my pen on the blue line and go up. So that we're shading everything above the blue line. Okay? Don't go insane here because we'll do pencil. Ooh, I probably should have said that first. Do pencil. All right, then we shade the red. Okay, so again, this is greater than. Okay, so greater than means we shade above. So everything above the red line. Bam, bam, bam. Okay, so then the solution is the overlap. So the overlap would be this part right here. That's where all the red and blue lines overlapped. Okay? And then this part right here, this would not be a solution. Anything over here. Over here, not a solution. So we'd erase that. Okay, so that wouldn't count. All right, so that's how you do an inequality. So here we have a lot of solutions. Okay, for instance, 0, 0, that's in that shaded region. That's the solutions. Example solutions would be like 0, 0. You also have, 2, 4. You have, let's see, we can go all the way out. We can say 10, 10. It's anything that's up there. Okay? So what did I say? 10 comma 10. You could have negative 3, 8. Okay, those are all solutions. Okay, you can even check them by plugging them in, right? If we plug in 0, you'd get 0 is greater than negative 1. That's true. 0 is less than 3. Also true. So we'd have a lot of like true points. Okay? So I like to throw those in there together because I feel like they're easy enough to put together, but if it's not, let me know, because I have been told by a lot of kids that sometimes when they go to the shading, they get to the solution part of this, it messes them up. So let me know if you get stuck, and I can help you figure out how to do more shading in class. Okay? All right. I'll see you next time.